try to do, oh my God, what's going on? Let's try to do the solution with no children, all right? The first thing we have to do is we have to have remove in BST, and remove in BST will first be like, well, if root is not null, okay, then we're going to, call, we're going to say root equals root dot remove data to remove. And that's an important thing here, because if root happens to be the childless node we're going to remove, it's the only node in there, then it's going to return null from that function, and that means our new root needs to equal null. Okay, so this is kind of the scheme we're going to do from here on out, and you'll see what I mean as we come down here. So now we have to do remove. What is going on? Ah! Okay, now we have to do remove. Did I have parentheses? Yeah, I have a parentheses issue. I have parentheses issues. Is that right? And then that right? Where does this go? Yep. And then where does this go? Yep. And then, oh, there is no parenthesis down there. Okay. Sorry about that. So we're going to return a BST node from remove, and the function is going to take in data to remove, right? And did I call it data to remove up here? Data to remove, I did. Okay, so I'm gonna call it data to remove down here just to keep it level so I don't drive myself crazy. It's just mad at me right now because we should be returning null. Okay, so I asked you to try to program this in the last one, the zero children case. So what's a zero child case? If the current node has zero children and the right equals null, no children, right? And the data to remove dot hash code equals our current data dot hash code. Okay, well in this case we're returning null. Okay, that is actually the case where we're going to return null. All right. Okay, so that is, oh, it's still giving me the red. Why is it being annoying? Actually, returning this is commonly what we're gonna do, but you'll see. We'll deal with it later. I'm just freaking out because of the red underlines. I just hate what it looks like. Okay, so that's the. I'm a node that has no children. What should I return? Okay. I'm a node that has no children. What should I return? Okay. So remember this case, right? So the reason we're going to return this, and I guess I did explain this to you already. The reason we're going to return this typically is because if you're not the node being removed, all right, then you are going to return yourself back up because that's what the child should point to up here. We'll do that in a second. This will make more sense when we start recursing, okay? So that should get rid of that. That's the zero child case, okay? Now let's think about the one child case. That means the node we want to remove is one child, okay? This node is the one we want to remove, all right? So that's another kind of base case here, right? So we have, let's say, 5, 4, 3, okay? And someone comes in and says, remove 4. All right? What's going to happen here? Well, it's actually not that hard, not that bad. So it's only one child, right? It only has one child. So this child should take its place, right? So this child can have a bunch of children and it can have whatever, right? But what really is happening is that this thing has one child, right? And we know that that child has to be less than 5. So we can just attach that child up here and we'll be good. Okay, so what's going to happen is 4, well, what does 4 need to return in the one-child case? Or what do you need to return in the one-child case to make sure that 5 now attaches to the child? Okay, what do you need to return? Well, that's something for the question, and then we'll come back and we will discuss it.